device manager functions. Device may be a keyboard, display, disk, parallel port, memory card, pen drive of the memory, network interface card, or a network device. These all are called as a devices. Device management ensures that a device is accessible to one task only at an instance. One task can access a device at an instance. That is the important thing. The manager coordinates between the application processes, driver, and the device controller. The controlling is going to be done through this manager. Manager is responsible for coordinating between the application processes, drivers, and the device controllers. The device manager's important components are, we'll discuss those things. First, we'll go for this device manager, a software that manages the device driver of each device. That is called as a device driver. See, take an example. Whenever you want to connect your printer to the laptop, you have to install one software. That software is called as a device driver software. That provides the accessing of the hardware devices through the for this softwares. That is a device driver. It also provides, device manager provides and executes the module for managing the devices and their driver ISRs. The device driver and the ISR corresponding to each driver. Each device has a separate drivers as per its hardwares. Each device driver facilitates the use of number of devices and the functions. Effectively operates and adopts the appropriate strategies for obtaining the optimal performance for the devices. It coordinates between the application processes, drivers, and the device controllers. Next is a device management has a three standard approaches. Three types of the device drivers are there. Programmed IOs by pulling from each device its services needed from each devices. See, programmed IO is a one method. Programmed IO by pulling from each device its the services needed from the device. That is the first one. Next one is a device uses the DMA operations. That is the another one. Second one is the interrupts from the device driver, device ISRs. This is the next one. These three are the device management has a standard approaches for the device management. See, programmed IOs, this is going to be done by pulling from each device its services needed from the each device. That is the programmed IO. Next is through the interrupts. Through the interrupts, you are going to control the devices. From the device driver to the device ISRs. This is the second one. Third one is the device uses the DMA operations. Through the DMA operations, you are going to provide the access to the memory. This is the three types of the device drivers. Next is the device manager functions. Device manager functions are device detection and addition. Here, providing a code for detecting the presence of various devices, then adding them for use of OS device driver functions. First detecting, then we are going to add that one for in the OS device driver functions. The manager may provide for tracking the hardware inventory. Through the inventory, a manager can identify the hardware. See, once you have installed some drivers, and if you install the thing that a printer device driver, then all the time it will be showing that one. Whenever you are going to be accessing any printer hardware, it is going to show that one. Once you have added, then it will be there in the OS. That is the thing. Next is the device deletion. It provides the code for withdrawing the resource allocated to a devices. It is going to withdraw the resources which are going to be allocated for the devices. Next is the device allocation and registration. Here, allocating and register a port. First it allocates and then it is going to register a one port. Through the port only the devices can be connected to the computers. So it is going to register a port. The manager allocates the devices at a distinct different addresses. Through the port, for the port, a distinct different addresses will be there. The managers also include the code which detect any collision between the addresses, and also it is going to identify any collisions are there in the network. Next is the detaching and deregistration. Detaching and deregistration a device or a port. The manager also includes the codes for detaching any collision between the existing addresses in case of address reallocation with the remaining attached devices. That is about the detaching and deregistration. Next, restricting a device to a specific processes. Restricting a device access to only one processes at an instance. That is this. Next is the device sharing. Permits the sharing of access of a devices to the set of processes, but to one processes at an instances. That is the device sharing. It gives the sharing of the devices between the processes, but one at an instance. Next is the device control. A manager can also provide for remote control of the devices from the remote server at a service providers. Through the service providers only the devices can be controlled. For example, through the mobile you can control the devices. Device access management, sequential access, random access, semi-random access, serial communication by the UART or a USB or a CAN. Device manager provides this necessary interfaces. This is about the device access management. You can use the sequential access, random access, semi-random access. These are the facilities are there for accessing the devices. Device buffer management. Device hardware may merely have a single byte buffer or a double buffer or a 8 byte buffers. A device buffer manager uses a memory manager to buffer the IO data streams from the device that sends the data and manages the computations without waiting for the buffer receives the data as a slow rate. Buffer management, it is going to manage the buffer. Whenever the buffer is full, it is going to stop receiving the extra data. When the buffer is empty, then it is not going to send any data. It is going to give an error. The buffer is empty. I cannot send any data. These all the things are going to be done by the device buffer manager. A device queue management. Manager organizes the device's I/O data stream of a device queue, circular queue, or a number of queued block of a queue. This queue will be there for the devices one after the because everyone want to all the processes want to access the devices. They have to wait in a queue processes. One after the other, the device is going to be providing the services to the processes. Next is a device driver. A manager manages the device drivers. The device driver or a software driver is a software for interfaces with the device hardware through the bus in one hand and for interfaces with the OS and the application at the other hand. It is going to be a middleware between the device and the operating system. Operating system applications will be there in the one hand, in the other hand the device will be there. It will be like a middleware between those things, that is a device driver. The it, See, it is going to have the functions. Through the functions you can access the device. Next is a device driver updating. A manager can also provide for updating the device drivers, or if internet is available then automatically it can do the updation and uploading of a new device functions which become available at a later date. That also can be done by the device manager. Backup and restoration. A manager can also provide for the backup and restoration for the drivers. You can keep the device functions as an backup and restoration. These all the works going to be done by the device managers. So, some set of command functions for the device management are there. They are create and open. It is create is for creating and open is for creating configuration and initialization of the device. Next is a write into the device buffer or send output to the device. That is a write. Read is write from the device buffer or a read input from the device. Next is a IOCTL, specified device configured for specific functions and the given specific parameters. This is used for accessing the specific partition information, defining the commands and control functions of the device registers, and also it is used for IO channel controlling. It is going to have the three arguments. We'll see later. First, we'll go for the close and delete. Close and delete. Close is a deregistration of the devices from the system. Delete is for, it is also close and detaching the device. This is about the delete. These are the commands are available for the devices. Now we will go for the IOCTL command. It provides the accessing a specific partition information, it defining the commands and control functions of a device registers and IO channel control. These all are the functions of the IOCTL. Arguments we'll see. It is going to contain the three arguments. First argument, it is going to define the chosen device and its functions by passing as an argument to the device descriptor. For example, for the files, we are going to use the file ID. Next, second argument, define the control options or uses option for the IO devices. That is the second one. What it is going to give some control options. If you want to take a accessing rate or data transfer rate, if you want to define, you can define here. That is going to be a control options. Next is the third argument, values needed by the defined function are at the third argument. What value you need, that will be there here. See, take an example, one example here, file ID, here this will be a file ID and here it is a accessing of the baud rates, file IO baud rate it is. If the baud rate is this one, it is going to access a data. FD is a device descriptor. Next, this is a function that takes the value, this one, from the argument. From this argument, it is going to take this value. This value, last one is, it is going to configure the devices for operations at this 19,200 baud rate. This is the one example of the IOCTL. Device driver ISR functions. Some of the functions are there for the device ISRs. One is a int lock to disable the device interrupt system. Int unlock, it is used for unlocking, enabling the device interrupts. Int connect, it is used to connect a C functions to an interrupt vector. Interrupt vector addresses for the device ISR points to its specified C functions. ISR means interrupt service routines. Next, int context finds whether the interrupt is called when the ISR was in execution. It is going to check this one. These all are the functions of the device driver ISRs. Next, we will move for the file system organization and implementation. File system organization and implementation. First, what is file? File is a named entity on a media card, magnetic disk, optical disk or a system memory. File contains the data, characters and the text. Or it may be a mix of these things. What is file? File is a named entity on a magnetic disk or a optical disk or a system memory or memory stick. It contains the data, characters and the text, and also it may contain the mixing of all these things. OS offering abstraction of a file. A file may be a named entity that is a structured record named entity as on a disk, which has having a random access in the system. It provides the random access to the system. Maybe a structured record on a RAM analogous to the disk. It may be present in the memory or disk, or it may be present in the RAM. May also either be called separately, called as a RAM disk or simply a file. You can call it as a RAM disk as well as a file, which is the data which is present in the RAM. You can call it as a RAM disk, or you can tell it as a file, or it is a virtual device. Maybe a unstructured record of a bits or a bytes. A file device may be a pipe like a device. File is also like a file like a device. What is pipe? Pipe is a first in, first out. Same way, the file may be a device. Next is the file organization in a file system. File organization in the system. File is organized in the way according to a file system which has a set of command functions for operations on the file. Some standard set of interfaces are there. Should a file having integer different from a file having a bytes? Should a file having a byte differ from the file having the character? No. Due to the offering approaches to the devices and the file management interfaces, the development of a set of standard interfaces that is there, that we have to check out. Two types of a file systems, block file system, another one is a byte stream file system. A block file system, its application generates records to be saved into the memory. First structured into a suitable format and then translated into the block stream. A file pointer points to a block from the start to the end of the file. File pointer means that is a file descriptor FD. That is going to indicating pointing to the from start to the end of the file. Next, byte stream file system. Byte stream file system, its application generates a record stream. In the stream, it will be recorded. streams are to be saved into the memory. These are first structured into a suitable format and then translated into the byte stream. It is also going to have the file pointer, that is called as a file descriptor. Point to the byte from the start index is equal to 0 to n minus 1. In the file, it is going to contain the n bytes. It is the file index is going to be pointing to the each byte, not the bits. Previously, from each bit, it is going to be indicating. That is the difference between the file and the byte stream. Next is the file device. File is like a device. File is a device, block device in a Unix, because it is like a, it is also going to have the operations similar to the device. Create, open, close, all the functions are similar to the device. So it is also called as a file. Next we'll move for the file descriptor. Every system is going to have the, every file is going to have the file descriptor. It is an integer which returns on opening a file and which points to the data structure. Next, data structure for the file descripting. What are the data structures will be there for descripting the file? First one is the identity, name by which a file is identified in the application. Means this is a file name. Next is a creator or a owner. Is it, who has created this one? That is a creator or a owner. Next is a state. It is in which state? It is in a closed state, open state, or a executing state. That will be giving the state. Next is the logs and protection fields. Here you can give the permissions for opening the files. You can give the permission or read only permission, write only permission, or only execution permission. That are the logs and protection fields of the file. Next is the file information. In the file information, it is going to have the current length, when created, when last modified, and the when last accessed. These all information will be there. If you want to check this file information, how it will be giving? Whenever you are, if you have any files in your system, you right click and go for the properties. There it is going to show the current length, when created, when last modified, and when last accessed. These all the information will be there in the file information. Next is a sharing permission. Can be shared for execution, reading, writing. That is a sharing permission. Next is a count. Number of directories referring to it. That is a count will be there. Storing media details. Block transferable per access. That is a storing media details. These all the information will be there. This completes the file system. Next we'll move for the IO subsystem. Next is the IO subsystem. The IO ports are the subsystem of a OS device management system. Driver use them to communicate with the many devices. The IO instructions depends on the hardware platform. IO system differs in the different OSs. We'll see how exactly it is going to be working. IO subsystem in a typical IO system in an OS. What are the things it is going to contain? Application, IO basic function, IO device driver function, device hardware or port or a IO interface card. First when we will go for the first subsystem hierarchy is a application. An application having the IO system. A sublayer may exist between the application and IO basic functions. This is about the application. Next is the IO basic functions. Device independent OS function. They are the IO basic function. Take an example. A file system functions for read, write, buffered IO, or a file read, write functions. This all comes under the IO basic functions. IO device driver functions. A device dependent OS function. They are called as a IO device driver function. They are depending on the devices. A driver may interface with a set of library functions. For example, serial communication device or a network. This comes under the device driver IO functions. A device hardware, network or a port or a IO interface card. These are the device hardwares for a devices. These are the IO subsystem in a typical IO system in an OS. Next we'll move for the IO operations. See how the OSs differing IO operation. Traditional OSs uses the synchronous IO operations and the RTOS uses the asynchronous IO operations. Synchronous IO operations means a fixed data transfer rate will be there. Here in the asynchronous IO transfer, variable data transfer rates will be there. You'll see in detail here synchronous IO operations. Here, synchronous IO operations are at a certain fixed data transfer rates. Therefore, a task blocks until the completion of the IOs. The task will be blocked until the completion of its execution. For example, a write function. Write function for a 1 KB data transfer to a buffer. This is the synchronous IO operation. The process task will be blocked until the transfer of the 1 KB of the data to the buffer. After the completion only a next operations can be done. Next is a asynchronous IO operations. Variable data transfer rates will be there. It is going to permit the process of high priority to run first. Then a low priority is going to be executed. It can be in the waiting state. That is a asynchronous IO operations. This completes your IO subsystem.